Next up for us is the tangent function. So let's remember that tangent is defined as sine over cosine. And if you look below, we have pictures of both the sine wave and the cosine wave. Sine is in purple, cosine is in green. So before we look at the picture, let's just look at one thing here. Notice that when cosine is a 0 in the denominator, we're going to run into problems. So we're undefined here and here. And then what sine is 0, we're going to have a 0 here and here. So let's pull out the tangent function. And there it is. If we remember from over here, I'm going to have undefined at the green. So at pi over 2 and 3 pi over 2, I am undefined. And notice, look what happens. The tangent wave does not touch the line where x equals pi over 2 or where x equals 3 pi over 2. It's undefined. And we can see that where the sine was 0, the tangent wave is going to go through 0. So let's bring back that lovely word, asymptote. So the tangent wave has asymptotes. Right there, and right there, and forever and ever. Now I'm only showing you part of the graph. So right here, at x equals pi over 2, we are undefined. At x equals 3 pi over 2, tangent wave is undefined. And that's because the cosine would have been 0 there. So again, just learning a couple of things about the tangent wave. If I were to ask you what the range is of the tangent wave, you would say it's all reals. In other words, this lovely picture of the tangent wave over here will pass through every y value there is. Remember, y's run this way. So if I started drawing all these lines, there's not one y value that the tangent wave will not eventually cross. I could keep doing that forever and ever. However, the domain is a different story. We already saw that we had undefineds here. Now there's a couple of ways to write it. There's the professional way, and then there's kind of the high school way. So one of the ways, we say the domain is all reals except, a slanted line like that means except dot 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 pi over 2, 3 pi over 2, 5 pi over 2, dot dot dot. Now what that is saying is the domain is every number in the world except, and then I formed a pattern here. And this pattern is pi over 2, 3 pi over 2, 5 pi over 2. So before this pattern and after this pattern. Now, for those of you who really want the professional, this is what it would be. The domain is all reals except k pi over 2, where k is odd integer. So, see right here? This would be 1. Well, let me use a different color. This would be 1. 1's an odd integer. 3 is an odd integer. 5 is an odd integer. Etc., etc., etc. So asymptotes could be written the same way. The asymptotes are anywhere where I have k pi over 2 k is an odd integer. And if you actually wanted to play something kind of cool, take out your calculator. I'm going to put mine in degree. And I'm going to pick a number. Let's take, we know this is 90 degrees. So let's take the tangent of 89, that number right before 90. And look what we get for an answer, 57. So that means if I were over here at 89, I'd be all the way up there. It goes off my page at 57. Now take the tangent of 89.9. Wow, just 0.9 and I'm up to 572. How about the tangent of 89.99? I'm all the way up to 5,729. So you can see this is rapidly gaining ground, getting higher and higher, but I'm never, ever, ever going to touch 90. I could keep doing this until the calculator runs out of memory and can no longer process. It just proves to you that we will never touch 90 degrees. We're going to get very, very close to it. We're going to get really, really high in the graph, but we're never going to touch it.